redo the whole thing. But please observe. Let's say I have a container and I have water. The blue thing is water. And I drop some salt, NaCl in there. Sorry guys. Yeah. Let's say I'm dropping NaCl in there. When I drop NaCl in there, it dissolves. But will it still remain as NaCl, or do you think it will become ions? Will it ionize? That's my question. Once again, when I drop NaCl salt, our table salt at our home, when we drop it, when we drop sodium chloride in water, it dissolves, and as it dissolves, what do you think happens to NaCl? Will it still remain as NaCl, a compound, or do you think it will divide as Na plus and Cl minus ions? That is my question, guys. I have an answer from Hasini. It says compound. Amrit also has NaCl. Will still remain as compound. What about others? You don't have to type in here, at least answer to yourself. Will it be as compounds or will it be as ions? Okay, I think most of you answered. Yeah, I have Samra also answering as compounds. Very good, all of you. I want you to pat your back. Whoever said compounds, please do a shabash to yourself. Do it. Come on, Hasini, everyone. Amrit, shabash yourself. And the answer is, it's ions. It's not compounds, guys. They can't remain as compounds. The mere fact that it's dissolving means the bonds between Na and Cl are broken and ions are formed. Okay. These are, whenever you drop them in water, they become ionic solutions. Yes, Hamsika just typed it, divides as Na plus ions and Cl minus ions. I was just kidding with you, asking you to pat your back so that you'll remember the mistake you just spoke about. So let's place some, all these are positive. Na plus ions, that's the plus. I'm using red. And for chlorine minus ions, I'm using green. Cl minus ions, I'm using green. All right. So I have another question. Right. So one more question. We already know that positive ions and negative ions, they have this attracting ability, right? Positive charges attract negative charges. So tell me this, do you think this, when you drop sodium chloride in water and you mix it up, it has all these ions, do you think they're attracting each other? Do you think they'll come closer and bond again to form NaCl? That's my question. It's still water. I'm not boiling the water or something. My question is, do you think this Na plus ion attracts this chlorine minus ions and they bond again? Do you think that could happen inside water? That's my question. So Amrit just gave me, yeah, Chandra Hasa, she was answering about previous question. They form ionic bond. Yes, fantastic. Sodium chloride is an ionic bond, and in water they divide and become Na plus Cl minus ions. And my question was, inside water, do you think this plus and minus again come close to each other? Can they bond each other? Because we know fundamentals. What we know is positive charges get attracted to negative charges. So Amrit just told me that they don't attract each other, or they don't come closer. Maybe there's an attraction, but they don't come close to each other and again form the solid NaCl. So why is that? The answer is correct. They don't combine again. But why are they not combining again? Logic and common sense tells us that they should combine. Positive charges should combine negative charges. But why don't they combine? Hasini says that energy is needed to combine. But it's a natural process, right, Hasini? Positive charges getting attracted to negative. It's a natural process. So they don't, Amrit also gave the same answer. They don't have enough energy to bond. In a way, you guys are correct actually. But think of it like this. Our connection could cancel out any second, guys. We need to come back quickly. I'll send a new link. But naturally, positive should come close to negative and attract, but it's not happening. That means there is some other force that is pushing these positives and negatives away. I hope you understand this. Both of them want to join each other. They want to come close to each other and become sodium chloride again. But there is some other force that is actually stopping them. So we are going to spend the next 1-2 minutes to understand that particular force, guys. Okay. So please focus hard in the next 2 minutes. This is not in your textbook, but I mean, maybe the textbook authors feel that you're supposed to know this or something. But anyway, uh, we have two compounds inside, right? When you add sodium chloride, there is sodium chloride, there is also water actually. Okay, so water is H2O. You already know that H2O. So H2O, the molecule, the structure, you can simplify it something like this. This is oxygen. No, that's not oxygen. Yeah. So this is oxygen atom or oxygen element. That's O. And let's have hydrogen here. So two hydrogens, H2O, right? So it's way smaller, guys. I'm sorry. It's supposed to be a little smaller. This is one hydrogen. And this is another hydrogen. That's water molecule. It's also ionic, if you remember. Water is also ionic, but it also has covalent bonds. And between one water molecule and another water molecule, there are hydrogen bonds. So these are positively charged. H plus, H plus, and oxygen has 2 negative, O minus 2, right? Yeah, we were using green for negative. Yeah. So this is water. Now imagine there is sodium and there is chlorine, and we used this red color ball or whatever. Imagine that's the sodium ion, and the green color ball or green color marble is the chlorine. Okay, so what's happening over here is the sodium and chlorine, they definitely want to come together. But what's happening over here, this oxygen that you're seeing, it starts to pull this sodium, or another oxygen from a different water molecule will pull this positive, and these hydrogens which are positively charged, they'll pull this negatively charged particle chlorine. Once again, oxygen of this molecule or oxygen at a different location, they will start pulling this sodium ion, and hydrogens of this particular molecule, water molecule, or hydrogens of a different water molecule, they'll pull the chlorine molecule. So essentially, even though these two want to come together, the forces of water, it's not just one water molecule. There are hundreds of water molecules that are doing this thing actually. So when they do this sodium chloride, they never can join back together because these particular things are pulled apart by these water molecules. Okay, so sodium and chlorine positive charges move in one direction, chlorine ions or chlorine charged particles, negative charge particles, move in the different direction. So ultimately, if you have electrodes, positive charges. Now, sodium chloride cannot be separated like this. Na and chlorine cannot be done, but you can think of copper sulfate or any other thing. So copper plus 2 ions will move towards one direction. Chlorine or copper sulfate, right? Sulfate ions might move in the other direction. Okay. And the reason this is happening is because of the electrolyte or the water that's inside that particular beaker. It is actually separating them. This separation is done by the electrolyte, and the force that is required to separate these ions is called the chemical force. This is very important in order to understand the battery. Let me check once the chat window for questions, and then I want to revise this, and then we can close it off for today. Sir, why do oxygen pull? Oxygen is actually, okay, I have question from Hasini. She just asked me, why is oxygen pulling sodium? Because oxygen is relatively negatively charged. Hydrogen is positively charged. I'm talking as relatively. Okay, relative means relative to the other substances, it has positive charge, and oxygen has negative charge. So since it's negative charge, it has this ability to pull the positive sodium ions, and hydrogen, since it's relatively positive charge, it has this ability to pull chlorine. So ultimately, what you need to remember is sodium and chlorine, they can't come together because a chemical force is actually given out by this oxygen. A chemical force is given out by this water molecules in the electrolyte, and those are actually separating them. The separation of ions happens because of a chemical force of the electrolyte. This is the most important conclusion we can draw, and that is crucial for understanding what happens inside a battery.